Hey everyone, my name is Deepak. Welcome to my channel. Today I'm going to show you how to test Kyverno policies locally before applying them to your Kubernetes cluster. Now, if you are new to the Kubernetes or Kyverno, don't worry. I'm going to explain everything from the basics. Imagine you are writing a security rule for your applications. You want to make sure only safe apps can run. But what if you made a mistake in that rule? What if it accidentally blocks everything? If you test it in your production system, this is a disaster. This is where your local testing comes in. You can test your rules safely on your machine, find out mistakes, fix them, and then apply them to your real cluster. By the end of this video, you will know exactly how to do this. Think of it as a manager for your application that is designed to automate deployment, scaling, and management of containerized applications. You tell it run this app, make 3 copies, and keep them running. And Kubernetes handles it automatically. The things Kubernetes manages are called resources. The most common one is called a pod, which is just a fancy word for running containerized application. You describe what you want using YAML files, which are just text files with specific format. That's all you need to know about Kubernetes. So the next part is, what is Kyverno? Kyverno is a Kubernetes native policy engine that lets you write and enforce cluster rules using simple YAML instead of code. Kyverno helps keep a Kubernetes configuration secret and consistent automatically. Kyverno is like a security guard for your Kubernetes. You write rules called as policies. Kyverno checks every resource against your rules. Here are some sample policies that you can check on kyverno.io/policies. Here are cluster policies, validating policies, mutating policies, generating policies, deleting, cluster cleanup policy, image validation policy. So Kyverno checks every resource against your rules. If something breaks your rules, Kyverno blocks it. Example rules might be all app must have a name label, don't use the latest version tag, every app need resource limits, and the best part is Kyverno is an open source project. So check out the GitHub link and start it. And you can also contribute into this amazing project by visiting github.com/kyverno/io. All the links will be provided in the description. You can test the policies on your laptop by using Kyverno CLI. Here's a blog that I have written, Getting Started with Kyverno, Your First Policy in Action. In this blog, I have guided you how you can install Kyverno CLI in your local machine, whether it's Mac OS, Windows, or Linux. Or the best part is you can go to playground.kyverno.io, and here you can write your policies and resources, and just you need to click on start. That's it, and you can test your policies over here. So now in this part, we are going to create a policy that says every pod must have a label called app. Labels are like name tag. They help you organize and identify your applications. I will create 3 files: the policy itself, a good pod that follows the rule, a bad pod that breaks the rule. So first let me create a folder. So here I have created a folder name as Kyverno. In this I'm going to write my policies. So first I will create a file called required labels.yaml, and now I will edit in this file. So here I have typed the policy itself. Now let me explain you line by line what does this mean. So first line says Kyverno policy version 1. Think of it like telling your computer what kind of document this is. Then kind cluster policy. Kind means what type of thing is this. Cluster policy means a rule that applies to the whole cluster. A cluster is your Kubernetes system. Then name required labels. Metadata is the information about the policy. We are giving it the name required labels. This is just so we can identify it later. Spec is the short form for specification. This is where we describe what the policy actually does. Everything below this is the actual rule. Validation failure action means what should happen if something breaks the rule. Enforce means blocks it, don't allow it. You could also use audit, which means allow it but warn me. We are using enforce because we want strict checking. Background true means also check resources that already exist, not just new one being created for local testing. This doesn't matter much, but it's a good practice. So rules. Here comes the actual rules. A policy can have multiple rules. We will write one. Name check for labels means we are starting a rule. The dash means this is a list item. We named it check for labels. Next is match. Match means what resource does this rules apply to. We are saying apply this rules to resource of kind pod. Remember, a pod is just a running application in Kubernetes. So this rule will check every pod. Validate means check if this is correct. This is where we define what we are checking. This is the error message. People will see if they break the rule. Always write clear message so people know what they did wrong. Like in GitHub, you write proper commit message. And this is the actual check. Pattern means the resource should look like this. We are saying in the metadata section, in the label section, there must be a label called app. So what does this question mark means? It means any value is fine, just make sure the label exists. Here's the complete policy. Let me save this policy. I will press escape, semicolon WQ and enter. And let me check for this policy. Yeah, it is saved properly. Now let's create a good pod in YAML. So I will create a new file, touch good pod.yaml. Now let me open the file in Vim. So here's I have written the file, the good pod. Now let me explain you everything. API version v1 means this is a Kubernetes pod version 1. Different from Kyverno pods are built into different Kubernetes. Kind pod, this is a resource, a running application. Metadata, we are naming this pod good pod. Labels and Nginx. Here's come the most important part. We are adding a label called app with the value nginx. This is what our policy is checking for. Since we have the app label, this pod will pass the policy check. In the spec section, this describes what runs in the pod. We are saying run a container packaged application called nginx using version 1.19. Nginx is a web server, just a common example. The important thing for our test is the label above, not what container does. Here's our good pod. It has the required app label, so it should pass. Right now I'm going to save it and write the other pod file, badpod.yaml. bad. So here is our pod file. This pod is almost identical to the good one. The only difference is it has no labels. No app label means it will fail our policy check. Now let me save this file and I will check that all three files are present here. It has bad pod, good pod, and require label.yaml file. Now here's come our testing time. So for this tutorial, I'm going to use Kyverno Playground. So for this tutorial, I will be checking all the policies in Kyverno Playground. I will run my policies here and and will teach you how you can use Kyverno Playground. So for now, I will be using Kyverno Playground to check the pod. So in this, I have written the required label, and this is the bad pod file. I will click on start. It should give me an error. So here you say the status is failed. Resource bad pod. It says rules, check for labels. And I can also validation error. Label app is required. Rule check. So here let me check. So it gives a validation error. Label app is required. Rule check for labels. Failed at path metadata labels. So now I have updated the file to good pod YAML file. Now this should work properly. So uses the status says pass, validation rule check for label passed, API version 1, pod, get pod. So it tells us exactly what's wrong. Why the bad pod failed because it has no label specified, and the good pod passed because it has the app label specified. So this is the power of Kyverno. So we just wrote a policy, create test resources, test them locally, saw what passes and what fails, all without touching a Kubernetes cluster. So let's move to the next part of the video. So now in this part, I'm going to block latest tag. So before getting started, what does this mean? This one is a real world best practice. Don't use the latest tag for container images. Why? Because latest is unpredictable. Today the version might be 1, tomorrow might be 2. This could break your application unexpectedly. Let's write a policy to block this. So first we will create a block policy. First we will write first we will create a file called block latest dot yaml. Now I will open this file using Vim editor. So here's I have written the file. So now let me explain what does this says. So this says we are creating a cluster policy called disallow latest tag. Next is specs, validation failure action, enforce mode. So this says enforce mode again, block fully. This we want to block latest tags, rule name require tag. Again checking all pods. So in the match, any resource kind pod means again checking all pods. In the validate section, this message says this is the error message. Using latest image tag is not allowed. This is the clear error message that will display. And in the last, image latest means this exclamation means not. The asterisk means anything. So latest means not anything with latest. Any file name that ending with semicolon latest will be rejected. So any image name that is ending with semicolon latest will be rejected. This time, this checks the image field of every container. If any image ends with latest, it fails. So I will save this file and create a new file, version pod.yaml. So here is the file version pod.yaml. So in this file, version tag is specified. This is not the latest tag, but this pod uses Nginx 1.19, a specific version. This is a good practice. This should pass. So now let me save this file and create a new file called latest pod.yaml. Now I will open this using Vim. So this is my latest pod.yaml file section. This pod uses latest tag. It's time to test them. So now let me save it. So this time also I will be using Kyverno playground to test the file. The rules name is require image tag. So for now I have copied all the data into Kyverno playground and I have uses the latest file data in the resources. So this should basically fail. So the status shows it failed. Now let's read the error. Validation error using latest image tag is not allowed. Rule required image tag field at path this. So this should typically fail. Now let's change this file to version pod.yaml. So now I have updated the data to version pod.yaml file. It should pass. See, here it pass. So this is the third example, which is required resource limit. So one more example, this is the production best practice. Every container should have a resource limit, how much CPU and memory it can use. Without limit, one app could consume all resources and crash everything else. Or if you are using cloud, this that could lead to a huge bill. Let enforce this with a policy. So first let's create a require limit.yaml file. So there's a slight changes. I'm writing the policy directly into the playground. So now let me explain you about this policy. In this policy, we are checking each container for resource section, limit section, memory, and CPU. This policies define this. And what does this means in memory and CPU? So here I have written a bad resource that has been not defined with any limit of memory and CPU. So let's run. It should give an error CPU and memory limits are required. So as you see, this fails and it says CPU and memory limits are required. So this is working fine. And now let's move to the other good policy. And now move to the other good policy. So this is the resource that has been defined with memory and CPU. So let's run this and it should run properly without any error. And you see this runs, the status is passed. So see how easy this is to define a policy and make resources. So this is also a part that I forgot to cover. So you can Instead of defining a single file, you can also define a whole folder, and inside there could be multiple resources, and you can check multiple files together using one command only. So, for example, if my file name is resource folder and inside it has multiple resources .yaml file, and I can just directly check the whole, I can just define the resource folder and it will check all of the files and give me an output. Right now um, I don't have installed Kyverno locally, so I'm not checking it, but you can also do this and it will give you output regarding the whole file. So now let's get, so now let's get to the next part. So let's recap quickly what we have done today. So we have studied what is Kyverno, a Kubernetes policy engine, why local testing matters because it catches mistakes safely, how you can install Kyverno CLI, you can check my blog out, how to write simple policies, how to test resources against policies. You can find the link to my blog in the description. If you find this video helpful, please like the video, leave a comment if you have any questions, subscribe for more Kubernetes content.